Hello, and welcome to this week's Ethical Dilemma in Science, where we examine a potentially controversial science-related topic in order to better understand the basic science concepts involved and the associated ethical debates. I'm John Hoffman, a professor of biology, and these scenarios are used in my scientific ethics seminar. So in this ethical dilemma, basically, what is the question we're looking at? And so taking a look at a variety of relatively recent articles that have come out during the summer of 2021, looking at what's going on within the American West. We're seeing long period of increased temperatures, decreased rainfall, contributing to a pretty significant drought. And within this region, we're seeing that the warming waters are, disrupting the fish population, actually causing a fairly significant fish kill. We're seeing that there are going to be efforts to kind of divert water within that region to areas that have needed it. But then there's a controversy, who gets access to this limited availability of water? And so, the title of this, Water, Water Everywhere, and Not Always a Drop to Drink, we take a look at the planet and we can see that the Earth's surface is covered with water by about 71% of the surface. Now, that's a lot of water when we take a look at it, but we need to recognize that about 96.5% of the water that is found in our oceans is going to be salt water. And so the vast majority of it is not in a form that we can readily use. If we look beyond that, we can see that there is, basically about 3% of the water that is going to be trapped in a variety of sources. It could be trapped in the ice caps at the polar poles, the glaciers, permanent snow, as well as groundwater kind of around the world. And so what this means is that less than 1% of the water on the planet is fresh water, water that we could actually drink, assuming that it's clean and purified in some way and accessible. And so 1% of the water on the planet is in a form that we can easily use it. And so if we take a look at this, and again, using information from UNICEF and the WHO, the World Health Organization, they did a study that was published in 2017, indicating that 1 in 3 people globally, 1 out of 3 people in the world today, do not have access to safe drinking water. What this means then is that there is a huge amount of people that are very vulnerable because they can't get access, ready access to life-saving, life-continuing water. In that study, they showed that, in the 15 years or so from about 2000 to when they started doing that study, they were able to get about 1.8 billion with a B, people better access to basic drinking water services. And so that's good. We're making progress, but still a vast majority of the population does not have access to the water that they need. And so this is especially prevalent if we take a look at those individuals living in rural areas. The data, again, from this study shows that about 8 in 10 people living in rural areas lacked access to these basic water services. And if we take a look at it, there are huge disparities, huge differences in the access of water between kind of the wealthy, the richest within a country, and those that are at the poorest percentage, with the idea that the richest people were twice as likely to have access to ready drinking water. And so what this means is for a vast majority of the world's population, they don't have running water in their homes. They don't have running water that they can run down the hall and wash their hands or get something to drink. What they have to do is either kind of go down to a river and stream, hope that it's relatively clean, maybe go to a well or some type of reservoir at some point, but they have to leave the home. They have to go out of the home in order to be able to collect the water in cans, in containers, in these buckets in many cases, and then carry it back to the home where it's going to be used. And so what we can see then is that for, again, the vast majority, or not the majority, but a large population of the world is dependent upon going out and obtaining water and bringing it back. And so what we can take that a step further and say, okay, if we've got water out there, how do we manage it? How do we make sure that it's getting to the locations that it's needed? And this is looking at water management strategies. Stepping back now from kind of human usage, but looking at kind of a viable ecosystem. And this is a slide looking at an area outside of Breckenridge, Colorado, where they basically, over a period of 2 years, went from the image on the top, where they pretty much just had kind of a dry upland region. And they allowed beavers to come in, dam the creek in this area. And within 2 years, we see the picture on the bottom, and where we now have a beaver-mediated wetland complex that is going to be, supporting, a whole variety of different organisms. And you can see the organisms that are capable of living in that dry environment on the top slide are going to be very, very different than the organisms that are going to live in this wetland complex that the beavers established on the bottom portion. So where does the dilemma come in? Where is the controversy associated with this? Take a look at this. Diversion of water resources is historically a source of conflict. We have this unequal distribution of water on the planet. We have some areas of the world where we have ready access and kind of a surplus of water, and people are able to use water without a second thought. And then we have vast tracts of land where they don't have access to water, and they are really vulnerable, because they've got to kind of go out of the way and either obtain the water, or in many cases have that water shipped into them. And this isn't a recent occurrence. We can take a look at kind of historically, one of the first recorded, historically recorded conflicts occurred in Sumerian legend about 2500 BC, looking at Mesopotamia. And so for those of us that, may not remember history as well as we would like, this is the Fertile Crescent. This is the area in modern day Iraq where the Tigris and Euphrates rivers are going to be present. And it was kind of the seat of very early civilization, at least civilization where we have, kind of recorded records that we can go. And when we take a look at this in this slide, looking at a little bit of a map of ancient Sumer in that area of Mesopotamia, we've got two city-states. We've got the city-state of Umma and the city-state of Lagash. And what we can see is that during this period of time, again, about 2500 BC, the Umma city-state interrupted the Euphrates River. And so the flow of the water down the Euphrates rivers, ultimately ending up here in the Gulf. And so what we can see is that Iraq here, Umma up here at the top, Iraq was the capital of the region. Umma kind of diverted the flow from these upper regions of the Euphrates rivers in order to get irrigation. In response, Lagash over here, needing access to water, basically dug channels to divert water from the Tigris River. And in doing so, that then cut the access of the Umma cities, the Umma towns, from their access of getting the water. And so we end up with this conflict of water, trying to figure out how we're going to get access to it. And about 1790 BC, so maybe 200 years after we're seeing this, maybe 250 years after we're seeing this conflict between Umma and Lagash, we have the Code of Hammurabi. Again, historically, thinking about that as one of the first written code of laws being present. Now, it's not a direct outcome of the conflict between Umma and Lagash, but if you take a look at this, and in the translation of the Code of Hammurabi, you can see that there are hundreds of laws dealing with irrigation systems and irrigation issues. And so we can see that there are, huge conflicts associated with access to water. And we know that, the cities of Umma and Lagash existed. We can find, archaeological records. Over here on the right-hand portion of the slide is this marble pillar that's housed within the British Museum. And recently they translated the Sumerian cuneiform. And what we see is that this marble pillar is actually a pillar that was used to stake claim to the territory and in essence, the water rights by the king of Lagash. And so again, finding, I was going to say concrete evidence, but in this case, marble evidence that this conflict that we've read about and heard about kind of in legends has some basis in historical fact. Now, going back to the United States, going back to modern day, what we can see using information from the U.S. Drought Monitor, as well as the U.S. Fish and Wildlife Service, is that the western region of the United States is under a fairly severe drought. If you take a look at this and the colors on the left-hand portion of this, the kind of orange is severe drought, red is extreme drought, and then kind of this darker, kind of burgundy color is exceptional drought. And I'm not sure how exceptional it is to be exceptional, but it's bad news. It's basically, we're seeing lots of high temperatures, lots of reduced rainfall, huge susceptibility of that region to wildfires. Currently, we've got a wildfire going on in Oregon, which is the third largest wildfire in modern history within Oregon. It's the bootleg fire. And so what we're seeing is that we have got this huge problem out there in the Western United States. If we take a look at what water is being used for in this region, about 70% of the global freshwater demand is used for agriculture, used for farming. And if we take a look at the topsoil in this region, what we can see is that the topsoil moisture levels are described as very short to short, basically not very good for growing crops. If we take a look at the rangelands and pastures where we have, like cattle grazing, other organisms kind of grazing through there, the quality of the soil because of this lack of water is very poor to poor. So again, not very good. And then finally, within this, or not finally, next, within this region, we've got a number of hydro power plants, hydroelectric plants that basically take the flow of water and allow it to kind of pass and spin turbines to generate electricity. One of the hydroelectric plants out there in the American West, the Lake Oroville hydropower plant, providing electricity to just under 1 million homes, about 800,000 homes, is expected to go offline this summer for the first time since it was constructed because of the lack of water flow within this region. In addition to that, we've got golf courses and homeowners and commercial companies that all want to have access and availability of water and get the services. In terms of what we're looking at with the fisheries, take a look at the Klamath River Basin up here at the border between Oregon and California, actually spans from Oregon into California. We can see that in this cluster, again, an area over here that is in the area of very extreme drought, we've got water flowing from kind of the mountainous regions all the way down through here, ultimately reaching the coast and flowing into the Pacific Ocean under normal circumstances. Now, if we take a look at this drought region that we're talking about right now, analysis by the Economic Innovation Group, so again, basically a think tank organization, took a look at the kind of growth in population, or at least the population dynamics in counties around the United States. And what they've seen is that the population in these drought-stricken counties in American Southwest are growing, and even to the point where the areas that have more drought, more severe drought at least, are experiencing more growth than in areas that have less drought associated with it. And so we've got this huge problem in that we've got limited resources available, limited access to water, and increasing demand with urbanization, building up of cities, as well as building up of the population in these areas. And so the problem, at least without a solution, without some type of intervention, is potentially only going to get worse. And so if we take a look at this, and again, the ethical dilemmas of the association, moving off of the Oregon, kind of California area, looking at the Colorado River. The Colorado River is the 6th longest river within the United States, roughly about 1,450 miles long, kind of starting out within the Rocky Mountains of Colorado, kind of passing through 7 different states, and ultimately, under ideal circumstances, flowing into the Colorado Delta down here in the Gulf of California within Mexico. Along the way, in addition to passing through 7 states, it's also going to pass through the regions of 23 tribal nations, indigenous peoples that are dependent upon the water flow as well. Now, this Colorado River Delta is actually dry in most years at this point. The water doesn't make it all the way down to the end of the river. It runs dry before we get there. Now, if we take a look at the Colorado River, it's considered to be the most controlled river in the world. We've got a series of dams that are involved with, kind of controlling the water flow, lots of hydroelectric plants to generate renewable energy, as well as distributing the water, allocating the water to a variety of sources. And so on this slide, we can see the outlined area of the Colorado River Basin broken down into the upper basin region up here, the lower basin region kind of below that, below the level of the Glen Canyon Dam and Lake Powell. And so basically at that boundary point, we go from the upper basin to the lower basin. But in this hashed area, we can see like Los Angeles over here, Las Vegas over here in this region, San Juan, Claro Project, over here, Colorado Springs, all kinds of different areas outside of the Colorado River watershed that have access or are receiving water from the Colorado River. It's being diverted and basically being used by areas outside of the normal range. And so if we take a look at this, even though the Colorado is the most controlled river, it's also going to be the most litigated river. There are the most lawsuits associated with this river as opposed to any other river in the world. And the reason for that is that virtually every job has been fully allocated. Every drop of water that is passing down the Colorado River is allocated to end up in some location. And it's not always going to make it to the Gulf of California down here at the tip of the river, the Colorado River Basin down here at the Colorado River Delta. Now, again, keep in mind, Colorado River, it's passing through 11 national parks, including the Grand Canyon, Whitewater Rapids, all kinds of other things, as well as just simply providing water to the area in that area. So how should we determine how these water resources should be allocated to ensure fairness and equity? We're building up California, we're building up Las Vegas, and they don't have enough water. Should we be diverting water from areas that have water to the areas that need it? And how do we do that in a way to ensure fairness and equity? The second ethical dilemma: what are appropriate measures to use in community water rationing? If we get to the situation where we don't have enough water available, who has priority? Who makes that decision? How do we determine that we're going to ration that water? And so a good example of this is the Cape Town, South Africa Zero Day, which occurred a few years ago. It was estimated in 2018, they were going to run out of water. And so basically in South Africa, they are dependent upon capturing rainwater within a reservoir and then using that water for the entire period of time. And so they had a series of time taking a look at 2015 2016, and then 2017, they had 3 years in a row with lower than normal rainfall, estimated to occur maybe once in about 590 years. But the situation is that over this period of time, over the last 20 years, getting into 2018, the population grew by about 80%, and the reservoir, the water storage capacity, only increased by 15%. And so what happened, again, with this day zero kind of controversy, day zero kind of crisis coming up, is that in February 2018, the reservoir that was providing the fresh water for Cape Town, South Africa, was at about 12% capacity. And they expected that they would have to turn off the taps by about April 16th. At that point, the only water available within Cape Town would be at distribution centers, and it would be rationed to the amount of 25 liters per day per person. Now, keep in mind, Americans, again, because of this unequal distribution of water around the planet, the average American is using 300 liters of water per day. And so because of that, we have this huge situation that there's not enough water that is going to be present in South Africa, in Cape Town with the day zero. So how do we determine how we're going to ration this very important but very limited access to fresh water? And then the next ethical dilemma, do regions have rights to water within the atmosphere? You may have heard of mineral rights. Mineral rights are property rights, at least within the United States, where a landowner can basically kind of sell or rent out the mineral, the rocks, the coal, metals, gems, potentially fluids like oil and natural gas. They belong to the landowner, but those rights can be sold or leased to another company to extract those. Now, in general, subsurface water, like you'd see in a water table, are usually allowed to stay with the surface right holder. And so if we take a look at that, then, who has access to the water? If we, instead of looking down into the ground, take a look at water within the atmosphere. And why is that important? Because we can have water in the atmosphere and still not have rain, still not have that water land on the surface and provide, moisture and be collected into reservoirs in some way. And so a good example of that is on the islands of Hawaii. We've got the prevailing winds kind of coming in here, and you can see kind of a lush, almost tropical region here. The white is actually clouds from the satellite image from the government climate site. And basically you got this very robust, very vibrant green growing area. And you basically have a mountain coming up here. And then on the other side, we've got the mountain going down. And so on the leeward side, the side away from the wind, we basically see kind of desolate lava fields where there's not a whole lot growing. And the reason for that is that the moisture within the atmosphere, as it's coming up to these mountains, is going to be pushed up into the atmosphere higher. It's going to cool down. And as it cools down, the water vapor in the air starts to coalesce or condense down into water droplets. And as those water droplets begin to get larger and larger, they ultimately become too heavy to be suspended within the air, and they're going to fall as rain. And so what that means then is that along the windward side, we've got lots of water vapor picked up by the Pacific Ocean. It's going to be flowing across here. As it's on the windward side, it's going to be pushed up, the air is cooling, and the rain is going to end up on this side. The rain is going to end up in this kind of lush green side over here. Who has access to the water within the atmosphere? And then finally, kind of related to the topic that kind of gave us the introduction to this, the ethical dilemma, should water be prioritized to support pockets of wildlife protected by the Endangered Species Act? The articles that I started looking at took a look at coho salmon Lots of different species of salmon around the West Coast, again, focusing in on the United States. In general, the Alaskan populations of salmon are in good shape at near target levels, but many of the West Coast coho salmons are overfished to the point that we've got one species that it's endangered and 3 species that were threatened. And so because of that, we have coho salmon in this region that are potentially at risk. And so in the summer of 2021, when we're taking a look at this, the federal officials involved with controlling access to water started to reduce the water going to the farmers in their agricultural fields in order to minimize the kill and minimize the impact on these endangered species. But is that what we should be doing? Should we be prioritizing wildlife over humans? Should we be prioritizing wildlife over agriculture? And so at this point, again, I've got spoilers after this. As Paul Harvey said, we're going to give you a little bit more information and provide you with the rest of the story. So in the first example, first ethical dilemma I had, how should water resources be allocated to ensure fairness and equity? When we take a look at the Colorado River is actually managed and regulated under a collection of agreements, laws, court decisions, contracts, the whole realm of things from local to federal levels referred to as the law of the river. And so that basically says that those individuals that had access to water kind of from early on are going to have priority, and a prior appropriation doctrine is what it's called, kind of legally. They should have priority. And so because of that, whoever settled into a region first has senior water rights. We'd have access or priority to get the water. And that's different than what you see in the eastern states like Pennsylvania, where you have riparian rights, where basically if you have access to waterways, if you have access to a river, you can use it. And then in the Midwest, we've got this kind of mixture of rights that are going to be present. But when we take a look at this, if we take a look at the water rights for the Colorado River, what we can see is that these rights are going to be a resource that can be bought and sold. And so if we take a look at this, especially within the lower basin of the Colorado River, we can see that it's being diverted to a whole variety of areas. It's diverted to Las Vegas up here, diverted to Phoenix, diverted to Tucson, going over here all the way to Los Angeles. So we've got this situation now that our law of the river, with this decreased rainflow, decreased snowmelt within the Rocky Mountains, the amount of water flowing down the Colorado River is less than what we've had before. And so what that means then is that we currently have more water allocated from the Colorado River than the river actually has. And so if you're down here at the end, again, that Mexican end of the Colorado River, it's running dry before it makes its way out to the ocean. The second, and so the question then becomes, how do we determine who gets access to water? What water resources should be provided in order to provide fairness and equity? And again, I'm not quite sure what the answers are going to be, but we've got a very complicated system in place right now. The ethical dilemma: what are appropriate measures to use in community water rationing? And so we go back to the Cape Town example. Basically, Cape Town, South Africa, is in the process of becoming a water-wise city. In 1998, the individual citizen used on average about 330 liters per day. By 2014, this had reduced by a third to about 220 liters. And when they had the fear of the day zero running out of water, in 2018, they were down to about 135 liters per day. And again, keep in mind, that's about a third of what Americans use on average. And so if we take a look at this, again, keeping in mind the need to be able to provide this in a fair and equitable manner, Cape Town already provides free water in the range of about 50 liters per day. That's kind of the World Health Organization minimum that's expected, about 50 liters per day to 500,000 people in informal settlements. And so basically kind of built up kind of regions without the infrastructure, without water kind of flowing through it. Now, keep in mind that 50 liters per day means that those individuals have to go to water stations with 7-liter buckets, collect the water, and bring it back home. And so if you're getting 50 liters of water, you're basically making 7 trips. Again, providing free access to it, but is it limited in its availability if they've got to go and get for it? Cape Town has implemented water management devices that cut off water once a daily limit has been allocated. But they've also done a lot of water kind of conservation activities. And so they're using alternatives for non-drinking water. And so they've got like rainwater takes. So they collect water in the city. They reuse it. They've replaced lawns with drought-resistant plants. And that's similar to what we've seen in Las Vegas, where Las Vegas is paying residents to replace ornamental grasses with drought-resistant plants. The next ethical dilemma were, do regions have rights to water within the atmosphere? You know, we looked at this as an example in the rain shadow. But this idea that water is basically going to be evaporating from the surface, go up into the atmosphere. As it cools down, it's going to condense, it's going to form clouds. And as those water droplets become heavy enough, they're going to become precipitation, and they're going to be rain or snow, depending upon what temperature is within the atmosphere. Now, all modern technology, and again, technology that's been used in place for about 80 years now, is cloud seeding. And so we've got a picture from the United Arab Emirates over here with this cloud seeding aircraft, where they basically kind of go up, fly through the air, and using these salt flares, just put material into the air, and that material kind of draws the water to it and causes these water droplets to fall. And so in the process of cloud seeding, they're able to go through and affect the flow of water in the atmosphere so that it's coming down in rain. And this has been used extensively within the United States. We see it in China, India, a whole variety of different areas. Within the United States, they've used it in Nevada, where long-term cloud seeding has increased the snowpack by about 10% each year. Controversies associated with this, again, the salts, there's some environmental issues associated with it, expenses and effectiveness concerns. In areas that they're doing that, you know, China is doing this up in Tibet, and India is concerned because a lot of the water that flows down from the Tibetan highlands also flows into the Ganges River. And so disrupting the water that gets into Tibet and the snow that falls in Tibet could impact the water that flows into the Ganges River, which is an important river within Asia. And again, within July 2021, the United Arab Emirates was basically experimenting, and they were able to use electrical stimulation and drones, as opposed to airplanes and salt, to trigger the release of rain. And so they are really the first within the Arab nations to use this technology to improve their water supply. And so, you know, the question is, do regions have rights to the water within their atmosphere? You know, is it appropriate that countries or even states can go through and do cloud seeding, or are they stealing water resources that would be available to others kind of further down? If we take a look at this, if we take a look at weather modification with this cloud seeding, you know, could this potentially be used as a weapon to kind of go through and prevent, you know, water from getting into an area, you know, put a country into an artificial drought setting, or, you know, trigger, you know, massive floods and rains as we go through and look at that as well. And then finally, the last of the ethical dilemmas: should water use be prioritized to support pockets of wildlife protected by the Endangered Species Act? We were taking a look, kind of the starting point was the coho salmon. What they've been able to determine is they had the big fish die off starting at the beginning of the summer. They decided that they were not going to release the fish, the baby fish, from the hatcheries until the conditions were better. But they had too many fish. And so what they did was they basically trucked many of these baby fish and then put them into other holding tanks, basically rearing tanks, where they're going to be held, and then they can be brought back to the Klamath River and then released. And so we've got this opportunity then, with these fisheries and the ability to, produce in these commercially interesting fish, coho salmon. But what are we doing for other organisms? What are we doing for, kind of less exciting, less commercially viable organisms that also need, ready access to water? So basically lots of questions, lots of controversies associated with it, not a whole lot of answers in these ethical dilemmas in science, but basically it's to introduce the topic to you so that you can think about it from a variety of perspectives and hopefully be able to better understand what the conflict is or what the controversies are. So thank you. Have a great day.